as a reminder, our context is we want to say something about the unknown population mean mu. And we're also assuming that the conditions, most of the conditions from the CLT are met. So we have those IID samples, we have a known and finite population standard deviation sigma, and for simplicity, we're going to work in the case where we have a normal distribution occurring, or the observations that we draw from are from a population that's normally distributed. We will satisfy, at least in the examples we see, that case of n being greater than 30, but we'll just work with that normal distribution. Okay, so now where do we begin? Okay, you might imagine that our goal is to get at this unknown population mean mu. Okay, and I just put it on the number line randomly. Okay, and back in chapter 13, we had discussed, okay, well, we know that the sample mean, right? The sample mean is what we call an unbiased estimator of mu. It doesn't systematically over or underestimate the population mean. So we can get a sample, right, and compute its mean, call that x bar, and it's going to be close-ish, depending on the type of sample depending on the variation present in the sample, but it's going to be close-ish to the population mean, but it's going to be off, right? And so what we want to do is give ourselves some grace and allow for some margin of error. Okay, but then if we include some margin of error, so I'm going to call this, let's call this E, and then we'd have this boundary, and then E, and then what we're going to say is that the population mean is within this interval, okay, x bar minus E, x bar plus E, okay, so it's going to be in there with some sort of confidence. A little more on that in a minute, but we want to know how do we quantify this margin of error, okay? So this is where our discussion of the CLT is critical, okay? So remember, when we're talking about the sample means, okay, the standard deviation of the sample mean is also called the standard error, was given by this sigma over square root of n. Okay, so we can use that, and so that can tell us, that can give us how much, right? Or like the units, I guess, the units of this error. We can say it's however many standard errors from the mean. But notice my language there, how much, right? That's the other piece that we need. We need to know how many of these standard errors away from the mean we're willing to go from x bar. Okay, and so that's this acceptable amount of accuracy. Okay, and so when we look at the margin of error, this E value, we say it's the standard error the standard error or the standard deviation of the sample means times what we call this Z alpha over 2. Okay, and the name for, there isn't really a nice name for this other than I call it the critical value, or a Z critical value. Okay, and if you're interested in how this is developed or how to quantify it, it does come from the standard normal distribution. Okay, and it's this Z alpha value here, and so it's an observation from the standard normal distribution. We'll get into a little bit more description of it, but right now it's a little vague, and I'm going to leave it as that because it's a little bit beyond what we need for this course. Okay, our main concern though is how do we get this? How do we get the margin of error? How do we get the Z critical value? Because sigma over square root of n, we've been doing that for a whole chapter, a long time, right? So to obtain the margin of error, okay, you can use confidence.norm. And actually, so whatever you get out of this is your margin of error completely. Okay, so type this in. There's this alpha value. I haven't clarified what alpha is. That'll become clear in the next video. And then you just enter your value of sigma and n, not square root n, just n. Okay, but we need to know what this alpha value is. More on that in the next video. The other way you can find this is, okay, you have your sigma over square root of n. You just need to find z alpha. z alpha over 2. And so to find this, what you'll do is norm.inv of 1 minus alpha over 2 0, comma 1. Okay, and then just multiply it. So that's two ways we can find this margin of error. We still haven't talked about alpha, so a little vague for right now, but that's okay. Nevertheless, we're now able to say, okay, well, we have a point estimate for the population mean, and we can extend out in either direction by our margin of error. And the interval that we construct here, so this is x bar minus e to x bar plus e, this is what we will call a confidence interval for the population mean. It's an interval that contains the population mean with some degree of confidence, or some, I don't want to say probability, but some degree of accuracy is associated to the population mean, or the interval that we constructed containing the population mean. Okay, so in the next video, we'll talk more about this language of confidence interval, margin of error, and in particular, talk about that alpha value.